This is section 172. We're going to continue looking at transformations in basic graphs. So we're going to know the 7 basic graphs, and we're going to apply horizontal and vertical transformations to those graphs. So I know that yesterday, or in the last lesson, we talked about the parabola, and that was the first parent graph that we introduced. And we said it had a standard form, and it had a starting position, right? And from that starting position, it was able to move horizontally or vertically. But now we're going to introduce other types of parent graphs. And each of these parent graphs, what makes them important is that they have their own unique shape. So for example, a cubic function in this form of x cubed has that shape. And that's what the parent function looks like with it. Now, just like with a parabola, you can shift it horizontally and you can shift it vertically. So that little quote-unquote starting position can move horizontally and it can move vertically. I know that I have this a written here. We're still going to talk about what that a does in the future. Now we have 2 more here. We have the square root function and we have the absolute value function. Again, based on the characteristic, square root, that's the shape. Notice the starting position, 0, 0. Notice the starting position, 0, 0 for the absolute value. Absolute value has this V shape. It still has the horizontal and vertical transformations. Then we have rational and we have exponential. Now, with rational functions, I know the shape's kind of weird, isn't it? They have what you call these horizontal asymptotes, and they also have vertical. So they have these horizontal and vertical asymptotes. And think of it like crosshairs, where this dot is going to move left or right or up or down, and those crosshairs are where the asymptotes are. With exponential, it's going to have this shape, but just know it's no longer 0, 0 where it starts. If you notice, it's starting at 0, 1. That's really important, and it's a common thing that a lot of students forget. It starts at 0, 1. It also has a horizontal asymptote at y equals 0. Now the horizontal asymptote will also shift with the graph. Now, I just want to introduce it, but we're going to come back to it later. We're not going to talk about this function yet. We're still going to get it down, but we're going to come back to it later when we talk about logs. But logarithms is also another type of function that starts at 1, 0, and it has a vertical asymptote at x equals 0. We need to get all of these down, flashcarded, and memorized. Now again, just like in the previous lesson, we can shift these graphs vertically. We can shift these graphs horizontally. So let's take this cubic function. What if I wanted to shift it 4 spaces to the left? Okay, that is affecting the x value. H, it's x minus h, so we do the opposite. So if I wanted to shift it 4 spaces to the left, well, that's in the negative direction. The opposite of the negative direction is positive, so it's going to be x plus 4. So it's x plus 4 cubed. It started from here, and that shifted over 4 spaces that way. If I wanted to shift it 2 spaces up, k, well, it's going to be f of x plus k. Because it says plus, plus means you do the same, and so it's going to be plus 2. You're going to shift your graph up 2 spaces. Normally it starts here if shifted up 2 spaces. If I wanted to combine that idea together, horizontal and vertical shift, x minus 2 cubed minus 3. Okay, well, because we're shifting to the right 2 spaces, well, to the right is positive. The opposite of positive is negative, so that's why it's x minus 2. And if we're shifting down, vertical shift, you do the same, so that's going to be minus. So x minus 2 cubed minus 3. Started here, shifted over 2 spaces, down 3 spaces. Every single point shifted over 3, or sorry, shifted over 2, down 3. Every single point shifted over 2, down 3. They all shifted over. If I wanted to shift to the left, so shifting to the left, that's negative, so that's going to be x plus 1. And then up 2, so that's going to be plus k. And so then shift it over, up 2. And it works that way with every shape. If I wanted to shift this square root function 4 places to the left, so if I wanted to go to the left, right, so that's in the negative direction, so that's going to be x plus 4, and then down 2, so then minus 2, but we have to put it in its function form, so square root of x plus 4, and then the minus 2. And then it normally started here, shifted over 4 spaces, down 2. If I have an absolute value function and I wanted to shift it 2 to the right and up 1, well, 2 to the right, so that's positive, so that's going to be x minus 2, up 1, so plus 1. But we have to write it in the form with absolute value. And so normally it starts here, shifts over 2, up 1. Same thing with the rational function. Those crosshairs, x minus 3, 1 over x minus 3 minus 2. So that means the horizontal shift is 3, shifts down 2. Those crosshairs shifted over 3 and then went down 2 spaces. So what did we learn today? We talked about the other parent functions when it came to transforming these functions. What does the absolute parent function look like? The absolute value is a v shape. It's the absolute value of x minus h plus k, and it does have that a in front. Put the parent graphs on flashcards and study them. This is important. This does conclude our lesson. If you have any other questions, please leave them in the comments.